Thanks again, patrons. Let's talk about our mission. We're going to talk about number 5 once again. If you want to read the rest of our mission, head to smashomash.com/forum/mission, smashomash.com/forum/mission. Number 5 is to publish scientific papers in a multidisciplinary manner, including sciences such as spectroscopy, and also including but not limited to the sciences shown on the screen there, like health, wellness, magnetohydrodynamics, etc. Spectroscopy, folks. It's kind of important. By the way, we're also on BitChute, thanks to our subscribers over there. There is exclusive content on all of our different sites, including Twitch, including BitChute, Twitter, Facebook, etc. And let's do a cosmology segment, as we'll be revisiting spectroscopy once again, one of the most important aspects of astronomy. Let's talk about the Big Bang. You may or may not believe the Big Bang was a thing. However, there is an interesting article at phys.org in the Astronomy and Space section regarding the Big Bang. Think of the expansion of the universe as a bread pan filled with dough and raisins. Think of the raisins as the galaxies and the dough as the space between the galaxies. As you expand the dough, the raisins are getting farther and farther apart. Or perhaps put dots on a balloon and then expand the balloon. That is the theory behind the expansion of the universe. Now, of course, some galaxies are blue shifted. Most galaxies appear to be red shifted. And I'm not going to get into the old light problem or anything like that in this video. I just want to refer our viewers to this article here on phys.org in the Astronomy and Space section. It may help you out about mainstream theories about the Big Bang. And today I won't poo-poo on the Big Bang or promote it. I'll just let the article scroll here. And feel free to pause. There are many misconceptions about the Big Bang. So perhaps have a read there, as there are some reasons to believe and some reasons not to believe that the Big Bang was a thing. And of course, one of my biggest problems with the Big Bang is the idea that the Big Bang created a monopole cosmic microwave background, as I think the cosmic microwave background is one of the most ridiculous things in all of astronomy and cosmology. Enough said on that. Today we're not going to pick a random object at all, which we regularly do on the videos in the cosmology segments. Today we're picking a non-random object. It's NGC 6553, a globular cluster located close to the Milky Way's galactic bulge. And I'm going to zoom way out so you can see about where this is located with respect to the Milky Way. It's on the Pan stars. So there you can see the Milky Way there. And if you zoom way in, you'll see NGC 6553. Now, globular clusters are like galaxies within galaxies. Very tightly dense, tightly packed regions of stars, consisting of various different stars of various different positions on the HR diagram, the Hertzsprung-Russell diagram. Let's check it out on the Spitzer. There it is in infrared light. And we'll also show you it in blue. This is the blue light spectrum, which occasionally shows additional features, as NGC 6553 is in the news today. So again, I would refer you to our mission. And notice how the first science that we list is spectroscopy. Why? Well, because radio astronomy is indeed the way of the future, and it's telling us more interesting things than largely anything else. So one of the things about spectroscopy is we look at it daily. For example, here's iron 9 and 10 at 171 angstroms. This is ionized iron, folks, and the UV light that it emits when it's in that spectral state. And what's interesting about NGC 6553 is, well, a couple of things. First of all, the vertical anti-correlation of sodium to oxygen, where there's a spread in sodium, but the variation in oxygen is minimal. So you've got a relatively consistent amount of oxygen across the globular cluster, but a totally inconsistent amount of sodium. Now, this is believed to be about 250,000 times the mass of the Sun, this entire globular cluster. I think it's actually even more than that. It's 235,000 solar masses is the estimated mass of NGC 6553. And I'm going to allow this article to scroll as well. And feel free to pause the video. Don't worry, we'll be here when you get back. Thanks to everybody who tunes in to our YouTube live premieres. And that's today's Cosmology segment. Let's continue on here at the Smash News Network. Least busted. Name in news.